Hello everyone again on my YouTube channel. Today I will continue in this chapter of data cleaning and preparation with a new concept. That's what's called outliers. So as we see here in the title, detecting and filtering the outliers. So when we're working in a project of data science and data analysis, we're gonna facing the outliers. So let me make this concept simple with a small example here as we see in this list of salary. Okay, let's consider this list as salaries and let's build in the definition of outliers based on this small example we have here. So as we see here in this list, let's check in all these numbers we have: 2,500, 1,500, 3,000, 3,500, 4,000, 5,000, 6,100, 3,800, 20,000. Well, this is salaries inside of this list. Well, let's see the mean of the salary to show you what's happening here. Well, it's add in a new cell. Okay, well, it's called mean. Well, I run it now. You see the mean of this list. So this is the mean 588. Well, here, if we consider all these integers or numbers we have inside of this list, is we have the variation between all these numbers is small. Okay, compared to the last one. As we see here, the variation, as I told before, is small compared to this last one. So here, that's what's called um, the outlier. So let's show you more here. I use here this package of Seaborn. It's very important package because that give us the ability to visualize our data and use some concept to detect the outliers like box plot. Well, here I will show you when visualize our data. I visualize the list. So this is all the range of data is stored here. But as we see, we have one values of 20,000 here is exist in the extreme of our curve. That's what's called the outliers. Outliers, it's we need to have some strategies to handle outliers because most of algorithms inside of machine learning it's sensitive to outliers. Okay, that means we can have the bias when we predict our values or any coming values. If we stay these outliers, we don't have handle it. Okay, so pandas of course provide for us some concepts to handle all these outliers. Okay, well, as I told before, we build in. So with outliers is some values, it's outrange. The variation between each point of all these, the last one is big. Variation store, the variation of all these we have here compared to the last one here in this list, in the same list, it's big, it's huge. Okay, well, we really that's what's called the outlier. We have some extreme values. Gonna found it in the right or in the left. That's different. Okay. Okay. Let's continue here. Well, here I create another random variable values. Sorry. So here this is normal distribution. The curve of is beautiful distribution. So each data scientist it's which to have this distribution inside of this, okay, because that's give you the idea. So here in this visualization, what we have, what is the interpretation of this visualization? So that means the most of data is concentrated here in the middle of this curve. This is the best the best curve. Okay, well, the most of the data, as I tell before, is concentrated in the middle of our curve here. And here, In the left and in the right, we have what's called the outliers. Here is the outliers view in both of sides, but most of data is concentrated here. Okay, that means the median and the mean and the mode it's near each other here. Okay, well, I create here a data frame based on this NumPy package and random values here. I try to create four columns with 10,000 point or 2,000 random values. Well, if I run it, well, this is my data. I try to see by default five records by calling this function of heat. Well, let's continue. So here, this is a function of shape. Give us the idea about how much of row we have and how much of columns, as we see here. Also, we have a famous, beautiful function that's called describe. For so this function of describe gives us an idea about the basic statistics. Well, if I run it here, so we can see how much of points we have on each column here with this function of count. We have 10,000, 10,000, 1,000, and we have also the mean for each column. So for column 0 here, so if we look, 10,000 of this point we have here in this column, the mean of this column is here. We have this mean is minus 0 point, and also for column 1 and 2 and 3. Also we have standard deviation. We have 1.00 also for column 1, and we have 0.99 for column 2, and we have 0.99 for column 3 also. So as we see here, we have standard deviation for all columns we have here. Set values for 0, 1, 2, and 3. Also, we have the function of minimum for each of the columns. Minus 3.53 for column 0, minus 3.66 for 1, for 3 we have also 3.63, and also we have minus 4 to 25 for column 4, and we have 20% of our data. We have less than this values, 20%. 20% of all the data for column 0 has these values or minus this value. Also for 1, for 2, and for 3, each of these values have its own each value. Well, for 50%, that means the middle or the half of data for column 1 have this value of 0.0059 for column 0, and also each of these column has its own values, and 74% and the maximum value for each of these columns. So this beautiful, the beauty of this described function give us an idea about each value we have, each variable or each feature we have in our data frame, to see or to build an idea and maybe to extract some information about the distribution and how it is. If we compare, for example, the median, because in statistics, as we know, sorry, the 50% does mean the median. Also, in we compare it to mean, does mean the median is more than mean. Does mean we have the right skewed here. The right skewed does mean the center of data it's going to right. Compare it to the mean. So the same things happen here. So we have here the median of this column 1 and the mean is near each one for other. Does mean maybe it's distributed more. So for column 2 and for column 3. Whereas we have also here the maximum values for each of this column. Well, let's continue. I will choose here this column 0, I run it. So this is the value we have in column 0. Okay, this is the value we have in column 0. That means the data for column 1, column 0, sorry. This is the data we have. Well, if we we consider, of course, this data is normally distributed. That means we have a technique or a trick to detect the outliers. That means we need to have or to see how much of data it's more than three deviation. Because as we know in a normal distribution, we have one standard deviation, we have two standard deviation, and we have three standard deviation. That means 95%, 99.9% of data is uh, have a variation with three or is far from the center of data with three deviation. Okay, that's what we do here also. Here, because as we know, if we check some data here, we have negative values and positive values. So to handle this problem, we need to call the absolute value here. In pay apps, I need to print all the data. It's more or more than three. So if some data it's a negative one, for example, we have 3 point something, negative minus 3 point something, it's more than three. We call the apps value, it will be positive. So here, if I run here myself, this is what I get. All this value is more than three. If we check, and we have 18 numbers or 18 numbers or 18 values is more or is respect this color, respect this filter or this condition I have here. Okay, this filter it's I so the result of this filter is 18. That means all the data here is verify my condition. Okay, all the data here is more than three. So for that's this process is for column 0. So if I pass also for column 1, okay, I choose my data just for column 1, and this is the result I take it. So 3.84, and all this value here is more than 3. Okay, so this is one trick to detect outliers. Of course, in a real world project, domain knowledge is very important, as I did before in the last sessions, because if you have a domain knowledge, that means you have an idea about all the important features, how it's distributed. If you have normal distributed or gamma distributed or t distributed or log distribution or exponential distribution, as depend of domain knowledge that's necessary. Of course, we have this transformation. If we can transform any any feature or variable we want based on domain knowledge. So let's continue with third column here. The same things, the same process. We have 19 here. We have 12. Sorry. We have 11. Okay, we have values here. So this value respect this condition or this filter we have here. So the same things happen with the last one, the fourth column. We have 12 values here, more than three. Okay, this is the technique we call for checking our data. Here, what I do is I plot these all these columns here, and this is the result what I get. So I plot each of this column, calling this plot distribution plot in package of C4, and I activate this KTE kernel density estimator. It's two. That's meant to give me this curve and see my my data how it is distributed. So well, this is one. So this is the first one. So as we see here, this bill curve show me is normally distributed. So for column 0, all the data is normally distributed. Okay, as we see here, this beautiful sheet. So the same things happen here for column 1. We have normally, so this distribution is normally distributed. Okay, that means the most of data is concentrated here between 0. So we have 3 and minus 3 here as we see. And if we look here, we have some outliers value here. It's more than 3. Okay, all these things in this tails, in this left tail is contain some outlier value. Well, also for type 1, the column 2, we have normally distributed as we see here. So look at normally distributed. We have some values also for normal, not perfect. Okay, uh, not perfect, but we have visualization show for us that is not, it is normally distributed. So the same things happen for column 4. Okay, how it's normally distributed. Well, let's continue. So here this syntax for us show for us, so we can select all the rows exceeding 3 or minus 3. Okay, so that means the values it's past 3 or minus 3, so we can return it here in this data frame. We can see here. Maybe we can transform it, or we can drop it as different kind of strategy we can follow after we understand in detail the problem and what is the needs of this project. So here we have this trick of np sign data dot hit. That's mean um, so the idea behind this function is to return for me all the columns or all the rows. It's replaced with minus or plus 1. Minus 1 or plus 1. All the values is replaced with minus 1 or plus 1. That's depend. Okay. If we have some negative value, that means we can replace it with minus 1. And if we have positive value, it's replace it with 1. But what is the importance of this function is so here as I create another data frame based on the old one, and if I multiply all the values here with 3, this is the result what I get here. I have minus 3 minus 1 here, for example, and when we multiply it with 3, the result is minus 3. What is important of this technique is I try to replace all the values exceeding minus 3 or 3 with 3. All the values exceeding the 3 or minus 3, I can replace it with 3 or minus 3. Okay, this is the idea behind this function of insights. Okay, so here I return all the values for the column 3. Okay, well, also here this is so here so this is the idea as I did before for this sign function. I replace all the exciting values for 3 or minus 3 with 3. Okay, if we have, for example, minus 3.01, will be replaced with minus 3. If we have 3.4, for example, it will be replaced with a 3. Okay, all the values excite 3 or minus 3, it will be replaced with 3 or minus 3. Okay, so after we are calling again this function of describe, we can see the difference we have. How we can detect the difference? It's with max function. We have here for all these value we have to, but if we check in again the old data frame with this describe function, we can see the difference. So sorry. So here, if we check in the max for column 0, for example, it's 4 point, and also for 1 we have 3 point, and here for 2 we have 3.55, and 3 we have 0.5. Okay, but if we after we are calling this function of sign and replace all the max value with 3, so this is the result what I get. Each value or each max value for all these 3 or 4 column we have is replaced with 3, and this is the idea behind sign function, is to replace or try to handle this data and make it in a center of our distribution. Okay, I hope that's clear for you all. Happy learning for everyone again. See you in the next session. Bye bye.